Welcome to Lahari tutorial for colorful chemistry. Today we shall discuss about a formation of coordination compounds based on a V.B.T, that is valence bond theory. Based on the valence bond theory, now we shall discuss the formation of different complexes having a coordination number 6 and coordination number 4. The first one is formation of FeCN6, the name of the complex hexaamine ferrate 2 ion. So here first we have to consider the atomic number of a central metal. Here the central metal is iron. The atomic number of iron is 26. The electronic configuration of iron, that is here argon 3d6, 4s2 and 4p. 4p is the outer orbital. Here the argon has a 18 electrons, that is atomic number 18. The argon belongs to the noble gas configuration. So 3d6, 4s2 and 4p. Here we can write as the for a central metal it has a 26 electrons. So in the 3d orbital there are 6 electrons, and in 4s orbital there are 2 electrons, and 4p is the outermost orbital. Now in this complex iron is in a +2 oxidation state. So it loses 2 electrons from a s orbital. So here in this complex the oxidation state of central metal is +2. So it loses 2 electrons from a 4s orbital. Now it becomes for the +2, that is the metal has a +2 oxidation state. Now the 3d electrons remains as it is. Here the 2 electrons will be loses from the 4s orbital. Now due to the influence of a strong field ligand, here the cyanide, okay, that is cyanide is one of a strong field ligand. So that due to the influence of a strong field ligand, the electrons, unpaired electrons present in a 3d orbitals are forced to pair up against Hund's multiplicity rule. Here the 3d electrons are paired up. Now for the complex FeCN6, here these electrons, means these unpaired electrons get forcibly pair up against the Hund's rule. So here the two now the vacant orbitals for a hybridization, 2d orbital, 1s orbital and 3p orbitals. Okay, these orbitals are involving in a hybridization and form the D2sp3 hybridization. So here the 2d orbitals, 1s orbital and 3p orbitals are involved in a hybridization to give a D2sp3 hybridization. Now the geometry of the this complex is octahedral. What about the hybridization? It is D2sp3 hybridization. So now the magnetic property become a diamagnetic. Why? Because see here in the complex there is no any unpaired electrons present. So here there is no unpaired electrons present in a complex, so that the magnetic property will be diamagnetic. Okay, if there is a unpaired electron present, so it becomes a paramagnetic character. So this is about the complex FeCN6. Hope you understood. Now the second example, that is the formation of a nickel Cl4 complex. Okay, the name of the complex is tetrachloridonickelate 2. Here the point will be same, but the thing different is the formation of a different complexes based on this coordination number. Okay, in the previous example, we have seen the coordination number 6. Now it is a 4. The atomic number of nickel is 28. The electronic configuration of nickel becomes organ 3d8, 4s2 and 4p. Here we know that 4p is what? It is the outer orbital. Now the central metal nickel has a 28 electrons, that is 8 electrons in 3d orbital, 2 electrons in a 4s orbital, and then here 2 electrons in a 4s and 4p is a outer orbital. So here in this complex, nickel is in a +2 oxidation state, so it loses 2 electrons from a s orbital. Okay, here in this complex, the nickel is in +2 oxidation, so this nickel atom which loses 2 electrons from a s orbital. So now the ion becomes, that is having a +2 oxidation state. So 3d, the electrons in a 3d orbitals will be remains same, and here it loses 2 electrons from a 4s orbital. Then the 4p. Okay. While forming a complex, electrons in a 3d orbitals remains unpaired because the chloride is a weak filled ligand. Okay, in a previous example, it has a cyanide ligand. It is a one of a strong filled ligand. Here the chloride is a weak filled ligand, so that the unpaired electrons in a 3d orbitals will be remains as it is. So here one s orbital and 3 p orbitals, one s orbital and 3 p orbitals hybridized to give a 4 sp3 hybrid orbitals. These orbitals are directed towards the corners of a tetrahedron. Here the formation of a complex, that is the 1s and 3p orbitals involved in a hybridization. Now we know that here it has the coordination number 4. So the 4 pair of electrons are donated by the ligand, and those electrons occupy in the hybridized orbitals. So the geometry becomes tetrahedral. Hybridization is sp3 hybridization, and the geometry will be tetrahedral. Now what about the magnetic property? The magnetic property becomes paramagnetic because here the complex has a unpaired electron, so that the complex has unpaired electron, so that the magnetic property becomes paramagnetic. So in the same example, okay, hope you understand the step-by-step process of formation of a complexes. Okay, these are this is a very important for a PU board exam. So means it is a satisfied answer for the formation of a complex. If they ask formation of a complex, you can write these 3 points. Okay, it is enough. Okay, I will discuss some more example in a next video. Thank you.